In some tissues, we have this scattering contrast mechanism. And being physicists, we very much wanted to pull this apart. Can we get the scattering part of this image away from the absorption part of the image? And that's what this is. This is a test object that has refraction. It's a lucite rod. Probably doesn't seem very medical to you, but it's a rod that gives us refraction absorption contrast. Paper scatters X-rays quite well. And so we use paper as a scatterer. And the next slide will show an image of this test object. What this is showing at the bottom is where the analyzer is set. So this is where we are in the rocking curve. And we've taken 24 images here. And what you see at the top are the images taken at those points in the rocking curve. And what you see is how DEI visualizes different types of things. You see the shadow on the rod. See how the shadow is white over black goes and then black over white? That's refraction occurring. It's shifting the peak around an angle. So that's how refraction appears. The shadow changes on features. And the paper is a really cool thing. If you look at the wings here, you see the white. That means there's X-rays being scattered out into this region. And we measure that when we're out here in the wings of the rocking curve. And we're in the very tippy top of the curve. It's just a few images here, by 2 or 3 of them. You notice how dark the paper turns. That's X-rays being scattered out of the direct line of sight. So we took this set of images with the intent of seeing, can we pull apart all of the things that are going on with DEI in this image? Meaning, can we pull apart the absorption from the refraction from the scattering piece? So we managed to do that. This is a refraction image of that object. So it may seem like a physicist game, but it's actually very important, because if we don't do this in cases where there is scattering and refraction going on at the same time, we are doomed. So we have to pull these apart if we're to make sense of these images. So this is refraction pulled apart separate from the absorption of the object. The cool thing, these are again new images to radiography. This is what we call a scatter image or extinction image. You can see it's found almost exclusively the paper. It found the scatter independent of the other things. This is what physicists love to do. And then in my case, we would like to translate this into applying it to medical problems, and we've already done that.